Okay, hello everyone. Myself is Dr. Pinke Sutaria, working as an assistant professor at Department of Chemistry, Bhavans College, Dakor. So, as we have started our organic spectroscopy chapter, okay, now in organic spectroscopy we have completed 3 lectures. Now in first lecture we have generally introduced as what is spectroscopy and the principle of the UV spectroscopy. In the next second lecture we have studied about the various electronic transition. In last lecture we have studied about the most important thing in UV spectroscopy, that is the 4 electronic shift, or what we can say the absorbance shift. Okay, so in which we have studied 4 most important shift in UV spectroscopy. That is first one, that is bathochromic shift. Okay, second one, that is hypsochromic shift. Okay, now this is a hypsochromic shift. Third one, that is hyperchromic shift, and fourth one, that is hypochromic shift. Now here we are having a lambda maximum, here also we are having a E maximum. Now bathochromic shift, it is also known as red shift. Hypsochromic shift, that is also known as blue shift. Now in bathochromic shift we are having a oxochrome group. Okay, in hyperchromic we are also having a oxochrome group. Okay, now both are having a oxochromic group. Here the lambda maximum is increases whereas polarity is decreases. Here lambda maximum is decreases whereas polarity is increases. Here we are having a E maximum, that is highest. Here we are having E maximum, that is lowest, or we can say decreasing. Okay, so these all things we have learned in our previous lecture. So in our previous lecture we have also studied about the 2 important terminology, that is a chromophore, okay, and second one, that is oxochrome. Okay, now these 2 important word we have already studied about the chromophore and oxochrome. Chromophore, that will impart the color, like we are having NO2 group and double bond N group. Okay, so these are the group that impart the color. Oxochrome will not give any color, but when we are reacting with A and B, if it is give a C molecule, when this C molecule will impart the color, then and then we can call this is known as oxochrome. In oxochrome we are having different type of group like OH, SH, we can have NH2 group, or we can have a NHR group or NR2 group. Okay, so these all groups are converted, these all groups are known as oxochromic group. Okay, so now in our today's lecture we will be studying about the what we can say that is the instrumentation part of the UV spectroscopy. So in any spectroscopy you have to remember that there will be the most important segment of this instrumentation part of in any spectroscopy. If you are studying about the UV spectroscopy, FTIR spectroscopy, NMR spectroscopy, or we can have a mass spectroscopy, instrumentation part is a most crucial part in any spectroscopy. So what instrument, or what we can say the spectroscopy, that is the theoretical part, and now we are talking about the spectrometer. Okay, now we are talking about the spectrometer. Now spectrometer generally carried out into the 3 segment. There are most important 3 segment. First one, that is a filter. Okay, second one we are having a, okay, second one we are having a prism, and third one we are having a grating. Okay, so now these prism and grating are the old fashioned instrument. Now in modern instrument we are converted in the filter. Okay, so you have already studied about the Michelson interferometer. Okay, so now this filter can be utilized in spectrometer. Now spectrometer generally has a different segment, like suppose we are talking about the source, second one that is a detector, third one that is a recorder, fourth one that is a monochromator. Okay, now these are the segment in which instrument can be utilized for the source, or we can have a detector, recorder or monochromator. So now let us start with our UV spectrometer. So that is a UV spectrometer. So let us write down over here, that is UV spectrometer. Okay, I am giving the block diagram for the UV spectrometer. So in the first we are having a source. Okay, source, it is the most important part in any instrument. Okay, so by forming a UV rays we require a deuterium lamp. Now this deuterium lamp, it is utilized to converted, or what we can say, to generate a UV radiation. Now this source, that is the three-dimensional light that falls onto the monochromator. Now what is monochromator? Monochromator which can convert it into the three-dimensional light into the one-dimensional light, or what we can say, polychromatic light. Okay, polychromatic light into the monochromatic light. Okay, so now this polychromatic light that is converted into the monochromatic light. Now this monochromator, now this UV radiation passes through the monochromator, then after it falls onto the a sample tube. Now here we are having a sample tube as well as the reference. Okay, now we are having a tube, one that is having a reference, and second one that is having a sample tube. Okay, now what is sample tube or what is a reference tube? Now sample cuvette, this is a one type of cuvette that we have been using in the UV spectrometer. Okay, now in which one we are having a sample tube and another we are having a reference tube. Okay, so now what is the difference between the sample and reference? Suppose if I want to take a graph of benzoic acid, okay, let's say benzoic acid. Now benzoic acid, this is our sample. Now as we know, this benzoic acid, let's say if it is soluble in acetone, so I will make a solution of benzoic acid into the acetone solution. So now acetone, that is our solvent. Now this acetone can be utilized for the reference. Okay, so now you have to remember that whatever the sample you are using, in which solvent you are dissolving your compound, that compound or that solvent can be utilized as a solvent. Okay, again I am repeating that if I want to take a benzoic acid graph, or if I want to take a benzoic acid UV spectra, so what I have to do? I have to take a benzoic acid as a sample material, and that benzoic acid can be soluble in any of the solvent. Suppose if I am talking about the acetone, let's say example, this is only example, benzoic acid plus solvent, that is acetone. We are mixing a solution, or we are making a solution by the benzoic acid plus acetone. Now this acetone can be utilized as a solvent, so I have to take a solvent acetone as a reference material. So this acetone and this acetone will be overlap, so I can get the only peak for the benzoic acid. Okay, so that is why reference is utilized. Now from this reference, the UV radiation is passed through the detector. Okay, so now here we are having a photo multiplier tube. Okay, that is PMT, that is known as photo multiplier tube. Okay, now here photo multiplier tube can detect the UV radiation and it will falls to the recorder. Okay, here we are having a recorder. Now this recorder, it is nothing but it is a computer. Now this computer will show a graph. Okay, the graph will suggest, one we are having a absorbance, and here we are having a lambda maximum, here we are having a particular graph. So now this graph suggests of the benzoic acid. Okay, so now let us revise again for the UV spectrometer. Okay, Now in UV spectrometer we are having first of all that is a source. Okay, for the source we are having, that is source, for the source we are having a mercury, okay, or we can have a deuterium lamp, okay, which can produce a UV radiation. Then after this UV radiation, it is passed through the monochromator. Here we are having a monochromator. Okay, now what is monochromator? Monochromator that can convert a 3-dimension light into the 1-dimension light. Okay, or what we can say, polychromatic light into the monochromatic light, that is known as a monochromator. Now here we are having a 2 compartment. First one that is a sample compartment and second one that is a reference compartment. Okay, so now this UV radiation falls to the sample compartment as well as the reference compartment. Then after it will travels to the detector. Okay, now detector we are using a photo multiplier tube. Now this photo multiplier tube can be utilized as a detector in UV spectrometer. Okay, now this detector will allow to the recorder to record a graph. What is recorder? Recorder is nothing but it is a computer. Now this computer can give us a graph like this. Here we are having a lambda maximum and here we are having a absorbance. Okay, so it will like this. So this graph will suggest our the lambda maximum, whatever wavelength we are having and whatever the absorbance we are having. Okay, so that will suggested by the this graph. Okay, so now two important thing you have to remember in UV spectrometer, that mercury or deuterium lamp will act as a source and photomultiplier tube that will act as a detector. So by that way you can memorize the UV spectrometer. Now in examination they will ask the UV instrumentation, so you have to draw or you have to explain whole the diagram by the block diagram. Okay, so that is the ultraviolet or you can say UV visible instrumentation part. Okay, so now let us discuss one important topic in UV spectroscopy, that is solvent effect. Okay, so now most suitable solvent is one which does not itself absorb in the region under investigation. Let's say a dilute solution of the sample is always prepared for the spectral analysis. Most commonly used solvent, that is the 95% of ethanol. Okay, ethanol is frequently used for the UV spectroscopy. Why? Because it is a base solvent, as it is cheap. Okay, it is not very expensive and it is transparent down to the 210 micron. Okay, you have to remember that whatever the solvent, whatever you are using, that does not interfere, okay, that does not interfere in UV region. Okay, let's say suppose 200 to 400 nanometer, that is our UV region. Suppose if I want to take a graph of benzoic acid, let's say suppose if I am having a benzoic acid, okay, and if I want to make if I want to solubilize this benzoic acid, okay, that is suppose if you are having a benzoic acid like this, okay, and if I want to make a UV spectrometer of graph, UV spectrograph, UV spectroscopy graph, so at that time I have to remember that ethanol, suppose if I am using ethanol, that ethanol should not give any intense peak in the region of 200 to 400 nanometer. So if I want to put graph over here, so I will get the graph benzoic acid in 200 to 400 nanometer. Ethanol will give around the 210 like here. Okay, so it will not interfere in the region of 200 to 400 nanometer. Let's say if it is given peak around that 180 nanometer, so it will not interfere in the region of 200 to 400 nanometer, that is our UV region. So that is why we have to take care whatever the solvent we are using, that should not be interfere. Okay, whatever the solvent we are using, that should not interfere in any region of the sample. Okay. Okay, so I have written one chart over the different types of solvent. Let's start from the ethanol, hexane, methanol, cyclohexane, diethyl ether, water and benzene. So this is its wavelength in micron, that is micron. We are having 210 for the ethanol, hexane, methanol, cyclohexane and diethyl ether. Water we are having 205 and benzene we are having 280. Okay, so hexane and other hydrocarbon can be used as these are the less polar and have least interaction with the molecule under investigation. For ultraviolet spectroscopy, like ethanol, water and cyclohexane serves the most important purpose. Okay, so by that way you can remember this, these are the solvents that can be utilized for the UV spectroscopy. Okay, so now question arises that what is the good solvent in UV spectroscopy, or what we can say what is its effect on absorbance maximum. So we can say that a good solvent in ultraviolet spectroscopy or visible spectroscopy is one which is low price and it is transparent around the 210 nanometer. Okay, so now in UV spectroscopy, the solvent should be transparent over the 210 nanometer. Polar bonds like carbonyls are affected by the solvent polarity. Suppose if you are increasing the solvent polarity, so this N to pi star transition, that is N to pi star transition, undergo blue shift. Okay, now as we know from the Weber, okay, that is our Weber, blue and red which is having a maximum intensity and blue which is having a minimum intensity. So when we are having N to pi star transition, that can undergo blue shift, while a pi to pi star transition can undergo the red shift. So you have to remember, when we are having a blue shift, at that time we are having a N to pi star transition. When we are having a pi to pi star transition, it means we are having a red shift. So what is the conclusion? The conclusion is that when we are having a pi to pi star transition, at that time we are having a maximum lambda, that is wavelength. Okay, when we are having N to pi star transition, so we can have a minimum lambda maximum, or what we can say, lambda maximum will be decreasing over here and lambda maximum increasing over here. So that is the conclusion for the N to pi star and pi to pi star. So in examination they can ask the question like this. Suppose if we are having acetaldehyde molecule and if we are having a acetylene molecule, okay, so in which we are having a maximum wavelength, or in which compound we are having a maximum wavelength. So you have to remember that pi to pi star, when we are having a pi to pi star transition, at that time we are having a maximum wavelength. So acetylene which is having a maximum wavelength as compared to the acetaldehyde. Why? Because it is having a N to pi star transition and pi to pi star transition in acetylene. So here we are having a pi bond only, and that is we are not having any heteroatom. So we can say that is having a pi to pi star transition. Here we are having N to pi star transition. So we can say that we can have a lower wavelength. Here we are having a higher wavelength. So by that way you can answer this type of question. Okay, so the question is, what do you mean by a good solvent in UV spectroscopy and what is its effect on absorbance maximum? So I will put this question in your assignment, so you have to answer this question. Okay.